Today we are in section 2-6 and we are talking about families of functions. In all of these functions we are going to start with a parent function, and that is the simplest form in the set of functions that form a family. So the most basic graph is considered the parent function. The first thing we are going to look at is vertical translation, and you've heard the word translation from geometry class. That's where you move the graph around left, right, up, or down. But since we're only talking about vertical right now, that is going to shift the graph of the parent function vertically, so obviously up or down, without changing the shape or its orientation. So to show you what vertical translation looks like, we're going to start with the parent function, f of x, and that's just going to represent any basic function. And now let's see what it looks like if we were to shift it or translate it vertically. So there are two types to shift it vertically, and that is f of x plus k and f of x minus k. So f of x plus k is going to shift your graph up. F of x minus k is going to shift your graph down. So now that we've looked at vertical translation, let's look at horizontal translation. So this is going to shift the graph of the parent function horizontally, or left or right, without changing the shape or orientation. Again, we're going to start with the parent function f of x as the most basic graph, and let's look at how it looks if we were to shift it horizontally. So these look much different than the vertical translation did. The h is now inside with the x. So if it's plus h or plus a number on the inside, that is going to move your graph to the left. If it's minus h on the inside, it's going to move your graph to the right. Now let's look at reflections, and this is going to flip the graph across the line, and we normally are only talking about the x and the y-axis. Again, we are going to start with the parent function f of x. So to reflect your graph across the x-axis, it's going to have a negative sign in front of your parent function. And to reflect your graph over your y-axis, this time there is going to be a negative inside the parentheses with the x in your parent function. A vertical stretch is going to stretch your parent graph up and down by multiplying all of your y values by the same number, and that number has to be greater than 1. So again, if we start with our parent function f of x, this time it is being multiplied by a number, and over here that number has to be greater than 1 for it to be a vertical stretch. A vertical compression is going to take all your parent graph and it's going to kind of smush it together like it's compressing it, and this is going to reduce all the values in the function by the same factor, and that factor must be between 0 and 1. So again, if I start with my parent function f of x, again, I'm going to still multiply it by that factor, but this factor is now greater than 0 but less than 1, so a fraction in between 0 and 1. So I need you guys to pull out your piecewise worksheet, and if you notice down here at the bottom it says 2.6, and you're looking for this part where it says your notes, okay? Those are the questions we're going to be looking at right now. So the directions at the bottom say, suppose the graph of f is given. Describe how the graph of each function can be obtained from the graph of f. So number 1 says y equals f of x minus 5. Now that number is inside the parentheses with my x, so this is like minus h, which is going to move it to the right 5. Number 2, y equals f of x plus 7. So that number is at the end, so it's like plus k, so it's going to move it up 7. 3, y equals f of x plus 1/2. I don't want you guys to be concerned because it's plus 1/2. It's still plus some number, so it's like plus k. So this is going to move my graph up by a factor of 1/2. 4, y equals f of negative x. Since this negative sign is inside my parentheses, that is going to reflect it across the y-axis because it was inside the parentheses. Number 5, y equals negative 1/2 times f of x. So if you look back at the numbers out in front, your vertical stretch and your compression from earlier in your notes, it said that a could be greater than 1 or greater than 0 and less than 1. So negative 1/2 is not in there, so you have to treat this as two separate things. So the negative out in front, this negative, is going to reflect it across the x-axis. And then this 1/2, that's right here, since 1/2 is in between 0 and 1, it's going to vertically compress it by a factor of 1/2. Number 6, y equals 3 times f of x minus 5. So that 3 is a, and since 3 is greater than 1, it's going to vertically stretch by a factor of 3. And then this minus 5 at the end is just like minus k, so then it's going to move my graph down 5. 7, y equals f of x plus 4 minus 3/4. So plus 4 is inside my parentheses, so it's just like plus h. So it's going to first move my parent graph left 4. And then this minus 3/4 is just like minus k. It doesn't matter that it's a fraction. So then it's going to move it down by 3/4. 8, y equals 2 times f of x minus 2 plus 2. So the 2 in front is a whole number, which is greater than 1, so it's going to vertically stretch it by a factor of 2. The x minus 2 is like minus h, so it's going to move my graph to the right 2. And then plus 2 is like plus k, so then it's going to move my graph down. Up 2. Okay, number 9, to the right of where 1 through 8 was, says the graph of f and g are given. Find a formula for the function of g. So this right here is my parent graph. And this is what I'm trying to find an equation for. So I'm going to pick a nice point. This point down here at the bottom is a nice point, and I'm going to compare how I got from that point to the exact same point on G. So it looks like I went to the right 1, 2, 3, 4. So I went to the right 4. It doesn't look like it went up or down, stretched it, or compressed it at all. So I have to start with my parent function, f of x equals x squared. And to the right 4, this is my h value, so that should be a minus h for it to move to the right. And so it always goes inside with the x, so I should have x minus 4 and then squared so that it's still its parent function. And that's my final answer to get from f of x to g. All right, number 10. So again, I want to know how it went from my parent function to g. And in this problem, it gives you a nice point of here and here to compare to. So from this point to this point, it looks like I went to the left 2. Doesn't look like I went down or anything. But how does my graph go from looking like this to looking like this if this was your x-axis? I hope you know that it looks like it's been flipped over, flipped across your x-axis. So I also need to add reflect x-axis. Okay, so the reflect x-axis is really easy. This is the one where there's just a minus sign out in front. And then the left 2, that comes from the h. So that's like plus h over here. And remember, that goes inside with the x. So I started with f of x equals the square root of x. So remember, your h goes with your x, so it's going to be plus 2. And then that minus sign is just going to go out in front of everything for it to flip over your x-axis. So now flip to the back of your piecewise worksheet so that we can work on some more notes. And again, make sure you're looking at the right-hand side. So part A says y equals f of x minus 2. Okay, that minus 2 is inside my parentheses, which means it's being moved to the right or to the left. And since it's minus, it's being moved to the right 2. So I take all of these 4 points and I move them to the right 2. And then connect them to make your shape again. And this is what y equals f of x minus 2 will look like. Part B says y equals f of x minus 2, and this time my minus 2 is outside of my parentheses. So this now means it's going to be moved down 2 since it was a negative. So you take these 4 points and you move it down 2. Connect your points. And your graph should look like so. Part C says y equals 2 times f of x. And since 2 is greater than 1, this is going to be a vertical stretch. And if you look back at your notes and you read your definition, it says you take the y value and you multiply it by 2. So I went ahead and I made a list of all of the points that are on our parent graph. And then we are going to take only the y values and we are going to multiply them by 2. So 0 times 2 stays 0. 4 times 2 becomes 8. 1 times 2 becomes 2. And 2 times 2 becomes 4. And now we can graph those points. And then connect your points And if you look, it looks like your graph has been stretched upwards. Part D says y equals negative f of x plus 3. The negative out in front, remember, means reflect and across your x-axis. And the plus 3, since it's at the end, means move it up 3. So I'm going to do this in two parts. I'm going to first reflect it over your x-axis. So since this point is on your x-axis, it's not going to move at all. From 0, or from the x-axis to this point, is up 4, so that means I go down 1, 2, 3, 4. So here's my new point being reflected over my x-axis. So from my x-axis to this point is a distance of 1, so I go down 1. From here to here is a distance of 2, so I go down 2. Now this isn't the final part, since you still have to move it up 3. So now you go up 1, 2, 3 from those new points. And now you get to connect them. And your graph looks like that. E says y equals f of negative x. The negative is inside the parentheses, which means you reflect it across your y-axis. So now we count the distance between our points and the y-axis. So this distance is a distance of 1, 2, 3, 4. So I go to the right, 1, 2, 3, 4. This point is on my y-axis, so it's not going to move at all. The distance from the y-axis to this point is 1, 2, so that means I go to the left 2. And then the distance from the y-axis to this point is a distance of 1, 2, 3, 4, 5, so I go to the left 1, 2, 3, 4, 5. Connect your points. It's going to look a little crazy, but again, it was reflected over your y-axis this time. Last one, f, y equals 1/2 times f of x minus 1. So 1/2, since it's in between 0 and 1, is going to be a vertical compression, and minus 1, since it's inside the parentheses, is going to move it to the right 1. Okay, so again, just like the vertical stretch, we need to multiply all the y values by 1/2 now this time. So I made a list of all the points, and I'm going to take their y values, and this time I'm going to multiply it by 1/2. So 0 times 1/2 stays 0. 4 times 1/2 becomes 2. 1 times 1/2 becomes 1/2. 2 times 1/2 becomes 1. So I'm going to first graph those points, and then I'll move those new points to the right 1. Okay, so now shift them to the right 1. Make sure that half still stays in the middle. And then connect them to get your answer. And if you notice, it kind of looks like somebody put their hand on the top of your graph and smushed it down. That's what a vertical compression looks like.